Going on? The first video, I want to kind of recap that Rascally Radicals videos that you were watching the other day. Now, you got your root sheet. Now, you're going to want to add some things to this square root part. Put that the square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. The square root of 225 is 15. The square root of 256 is 16. Okay, because you're going to need that high. Okay, now with adding and subtracting radicals, first off, we want to get all these radicals simplified. So the 8xy will just drop. Okay, and then minus, and then these two radicals, we're going to come over here, make a little table, and simplify them. So I got the square root of 25x squared y squared. And then I've also got the cubed root of 8x to the third, y to the third, okay? So we want to simplify the square root of 25, the square root of x squared, and the square root of y to the second. And over here, we're going to simplify the cubed root of 8, the cubed root of x to the third, and the cubed root of y to the third. Okay, so 25, this is a square root, this is a cube root. So 25 is a perfect square, that's 5. Now, the square root of x to the second. Now, remember, if it's a square root, we're grouping the x's by 2. That would be one group, so I write x. There wouldn't be any left over. Okay, so the radical there goes away. And the same thing happens with y. So this is now 5xy. So I have simplified that, 5xy. Now, over here, we're a cube root. Cube root of 8 is 2. Now you'd group them by 3s. Well, if you got 3 x's, you're grouping them by 3s because you have a cubed root, so it's groups of 3. That would be 1x. It's really just dividing, okay? That's going to be y, so it's 2xy. So plus 2xy. Now these are all like terms, all three of them. They all have xy after them. We just do the math with the coefficients. 8 minus 5 is 3. 3 plus 2 is 5. It's going to be 5xy in the final answer. Okay, adding, subtracting, you want to simplify with kind of tables, and then multiplication. Okay, multiplication, you're not going to go over here at all. Well, actually, you are. Okay. Multiplication, I don't simplify I put the radicals together with the multiplication operation. You can't do that when you add and subtract, but multiplication, look for anything outside. There's nothing. So you make your radical, you take 5 times 20, that's 100, and then the x times x to the third is x to the fourth. Then you're going to simplify that. Again, that's kind of like step 1. Multiplication is kind of a two-step process. Step 2, you're going to go over here and simplify. Square root of 100, square root of x to the fourth. So these are square roots. The square root of 100 is going to be 10. And again, the square root of, again, you're grouping it by 2's. Remember, if you don't have a radical index, it's a square root. So how many groups of 2 can you get out of 4? You can get 2, so x to the second, and there wouldn't be any left over. So this is 10x to the second. Again, usually with adding and subtracting, you have to square your starting radicals independently. But with multiplication, as long as they're the same roots, they're both square roots. If that was a square root and that was a cube root, I'd have to kind of take another avenue, which isn't pleasant. Okay, addition. So we're going to put the fourth root of 32x and the fourth root of 2x to the fifth. So I got the fourth root of 32 and the fourth root of x. Now you're dealing with fourth roots now, so you're going to divide 32. I think 32 will divide by 16. Okay, so I rewrite that, fourth root, we're dividing it by 16, and we get 2. Now the fourth root of 16 is equal to 2. Okay, so we have an outside 2 and then a fourth root of 2. Now this is just x. You're grouping them by 4s. You can't get a group of 4 out of that, so that's already in simplest form. Okay. So what I do is I make a fourth root because there's some, and inside I got a 2 from up here and an x there. Now we also got a whole factor of 2 out there. Okay, so I rewrite this as 2 fourth root 2x plus. Now I come out here. Okay, now I don't think 2, other than 1, 2 really can't be divided by any of these, so that's already in simplest form. However, this is not, because if I have 5 x's, I can get one group of 5 out, and there'd be still an x left in the fourth root. Okay, so I still have a fourth root with a 2 and an x inside, and then outside I just got x. Okay, so I rewrite that as x with a fourth root of 2x. Now the radicals are the same, okay? So what I do is I can combine those. I have the fourth root of 2x. That's what I've accomplished. Now outside I have 2 plus x. Now if that was a number, 2 and 3, I'd add 2 plus 3 and write 5. But because we don't know what number x is, we write the expression 2 plus x and put a parentheses around it. There you have it. Okay, another multiplication problem, but this time you got a little problem. You have the fact that you have a cubed root and a square root. So what you need to do now is rewrite this, so instead of the radicals you have exponents. So that's 3 to the 1/3 power times 10 to the 1/2 power, 4. Now, then what we do is we simply distribute the 4 to each exponent in there. So I just take 4 times 1, that's 4, so it'd be 3 to the power of 4/3. And then 10, 4 times 1 is 4. 4 divided by 2, though, is 2, so that'd be 10 to the second. Now, we know we can simplify the 10 to the second. That's easily. That's 100. So I'll put the 100 first. Multiplication's commutative. Now, 3 to the 4/3 power, okay, I'm not sure what that is. So what I do then is make a root. Now, the bottom number tells you what kind of root it is. It's a third root with a 3. And you're going to raise that to the 4th power. Now, I really can't divide 3 by any of these cubed roots, so what I'm going to do is do the power operation first. And it doesn't matter. You can switch them. You can find the root, whatever's convenient. Here, finding the cube root of 3 is not convenient, so I raise 3 to the 4th power. That's 81. Okay, now 81 is not a perfect third, but now what we can do is we can now split it into 2 cubed roots. So 81 divided by 64, no. 81 divided by 27, it works. 27 and 3. So the cubed root of 27 is equal to 3 whole. So over here we're going to put 3 with the cubed root of 3. Okay, now multiplication, I'm going to want to multiply the outsides. 100 times 3 is going to be 300, okay, with the cubed root of 3 attached. It's like taking 100 times 3x. You'd take 300 with the x attached. So again, that's how you're going to multiply when it's a problem with the radicals are different. You're going to rewrite them. If there's a number to distribute, then you simplify each factor individually, okay? Now again, if it doesn't work like that 3 to the 4th, you got to analyze it a little bit. Okay, then our last one. Okay, this is the easy one. 4th root of 48 and the 4th root of x to the 5th. Okay, so 48, remember we're dividing by 4th roots. 48 is divisible by 16. Because if I divide 48 by 16, the result is 3. So that becomes then 2. Okay, now remember, you're thinking grouping. With variables and exponents, you want to think groups. So I get one full group, but there'd be one left. Okay, so I make my root, my 4th root. Now there's a 3 and an x inside, and then outside you have a 2 and an x. So there you have it. You got 2x, 4th root of 3x. Okay, and that pretty much covers the radicals. Now, rationalizing the denominator, that means they want the square root out of the denominator. Okay, so what you're going to do is make another line. You don't have any plus or minus expressions, so you're just going to multiply by the square root of 5 and then also by the square root of 5. You're essentially multiplying by a 1 fraction value of 1, because anything over itself is 1. But now I do the math, okay? 2 is whole, 5 is a square root, so I put 2 square root 5. Now these are both square roots, so we go ahead and multiply those. So that's going to be the square root of 25, but we know that the square root of 25 is 5. And that's the answer, 2 square root 5 over 5. Okay, now the next one, they want the square root out. Now if you have pluses and minuses, you want to put those in parentheses. Now remember the denominator. So what you have to do now with the plus expression, you're going to write 2 square root 3, and you're going to write 3, but instead of plus, you're going to have minus. And then likewise on top. And you have to do the FOIL method then. Okay. So we'll be taking square root of 3 times 2 square root 3. Then we'll be taking the square root of 3 times negative 3. Then we'll be taking negative 1 times 2 square root 3. And we'll be taking negative 1 times negative 3. So here I got my factor of 2. And the square root of 3 times the square root of 3 is the square root of 9. But we know the square root of 9 is 3. So I take 2 times 3, and that product is 6. Here I can't multiply. That's a square root, that's a whole. But I put negative 3 and put the square root 3 behind it. Okay, negative 1 times 2 would be negative 2. I multiply the two outer factors, and then the square root of 3 stays like that. And then negative 1 times negative 3 is 3. So what I have on top now, I can combine 6 and 3. That's 9. And then I can also combine these, because they both have a square root of 3 connected. So negative 3 plus negative 2 is negative 5. And I just attach the square root of 3, because those are like terms. Okay, now on the bottom is where it's going to get simpler. So I go 2 square root 3 times 2 square root 3. Then I go 2 square root 3 times negative 3. Then I go 3 times 2 square root 3. And then I go 3 times negative 3. So again, I multiply the 2's to get 4 and the square roots to get 9. The square root of 9 is 3. So 4 times 3 gives me a product of 12. 2 times negative 3 is negative 6 with the square root of 3. 3 times 2 is 6, square root of 3. Now in the middle, they're the same number, except this is negative, this is positive, meaning they cancel. And here you got negative 9. So 12 and negative 9 then make 3. That's your product. Okay, now simplifying with these exponent fractions. Okay, now you got to dig deep here. You got to know what this actually means. Okay, so it's a positive exponent. That, by the way, it's a power, 16 to the 3. I'm not a good power writer. Okay, you're going to make a radical, and it's a square root because that's your bottom. The bottom tells you what that is. And then after that, you have to the third power. Now again, you can go 16 to the third first and do the square root, or you can do the square root and go to the third first. Now it's whatever's convenient, but I think if you look on this, 16 is a perfect square, so I'm just going to get rid of my root first, and it's 4 to the third. 4 to the third then, 4 times 4 times 4 is 64. So this is equal to 64. Okay, now the next one, same idea. You got a root, 25 inside. Now that bottom number tells you what the root is, and then you're going to put a third outside of it. Okay, so the square, again, it's going to make sense to do the root first because 25 is a perfect square. It's 5, and then we raise the 5 to the third power. That's 125. Okay, again, right here, got an 8. Now it's a cubed root this time, raised to the second power. Now again, it's going to make sense to do the root first because a cubed root of 8 equals 2. So 2 to the second then is 4. Okay, 16. Fourth root, raised to the third power. So again, we can do the raise it to the power first or do the root first, but it's going to make sense to do the root first because the fourth root of 16 is 2. So 2 to the third. So 2 to the third is 8. Okay, now remember what I told you to do with a negative power. You're going to make it positive as long as you come over here and put a 1 over it. Okay, and now we do the same thing. Now don't make the 81 positive. The negative 81 goes in a root. Wait a second. No, that needs to be positive 81 because you can't, the root's a 4, okay? You can't have negative numbers under an even root, okay? That's undefined. And the reason why is because you can't multiply something an even number of times and get a negative. You can multiply it an odd number of times and get a negative, but not an even, okay? So again, I think it'll make sense to do the root first because you'll have 3, and then 3 to the third is 27. Okay, now the next one. Again, even though that's a fraction, you're going to put a 1 over it, okay? And we make that a positive. Now, here with this fraction, what you're going to want to do is kind of split it in 2 parts. You're going to have a root, so you're going to have 8 first, 27 second. Now, they're both cubed roots with the second power here. Now, let's talk about the cubed root of 8. Now, you run into a... No, this one. Yeah, cubed root of 8 is 2. So it'd be 2 raised to the second power, so that's 4. Okay, and you're going to put a fraction down there. So 4 is on top, and then here the cubed root of 27 is 3. 3 raised to the second is 9. Now, when you're taking 1, again, dividing fractions, it's like 1 over 1, and then we'd flip the bottom to 9 over 4. So that's 9 over 4. So really, when I divide 1 by a fraction, the fraction on bottom just flips. Okay, now next one. Remember what the game plan. Put a 1. If you see a negative power, you're going to make it positive. Okay, and roots, and then negative 64 and 125. Now the 64 can be negative because the root is an odd degree. Okay, you can multiply 3 things together to get a negative. You can't multiply 2 or 4 because that always ends up positive. Then both of them are raised to the second power. Okay, now the cubed root, this is going to make sense to do the root first because that's on here. That's 4, but it would be negative 4. But when I take negative 4 to the second, it's 16. So we have 16 there. Okay, the cubed root of 125. Again, 125 is there. It's 5. 5 raised to the second is 25. Now, again, that's just going to end up 25 sixteenths. Because, again, it'd be like 1 over 1 times 25 over 16. Okay, now the next one's going to be a little bit dicey. You're going to still do the 1. You're going to split this up so it's 2 roots. So you got root, 8, and 9. Now it's a square root. And then, because that's the bottom, and then it goes to the third power. We run into a little problem with the 8, and that's the fact that we're doing square roots, and 8 does not appear to be a perfect square. So in this instance, it would make sense for me to get the power done first. So 8 to the third power is 512. Now you make 2 square roots, and you're going to divide 512. Okay, start at 256. That's why I had you put that. Okay, I'm able to divide by 256, and I get 2. So we get rid of the 256 because we know that's 16. Okay, so over here, we're going to have 16 square root of 2. It's a square root, so you don't have to put the little number there. Okay, now again, 9's a perfect square, so that would be 3. We do the root first, then the power, and that'd be 27. Okay, so you know you're going to just flip that, 27 over 16 square root of 2. But if you look in the back of a textbook, that's not the answer. Because remember, we want to get the square root out of the denominator. Okay? Well, there's no plus and minus to parenthesize, so we can just multiply then by the square root of 2. Okay? And basically, essentially, instead of doing that, let's just get rid of the square root. And now I can take 16 times 2, which is 32. But then I need to then multiply the top by the square root of 2. So that'd be 27 square root of 2. Because multiplying the bottom by the square root of 2 would just become square root of 4, which is 2. And then 27 square root of 2. Again, the back of the book does not want square roots in the denominator. Okay, now, next one. You need to add those fractions, okay? So what you're going to do first is make two giant fraction lines, and you're going to rewrite those radicals as rational exponents. So that's going to be 86, 8x plus 1 to the 1/3 power. And over here, you're going to have parentheses x minus 2 to the 1/3 power. Over here, you're going to have 3 times, and you're going to rewrite that as parentheses x minus 2, but it's going to be to the 2/3 power because there's a 2 out there, power of 2. And then likewise over here, you're going to have 24 times, and then you're going to put 8x plus 1 in a parentheses, but it'd be a 1/3, but there's a 2 there, so it'd go to the 2/3. Okay, and we need to come up with the lowest common denominator. So on bottom, you got outer factors, you got the 3 and the 24. So you got outer 3, outer 24. Now you've also got the parentheses. Remember, when I'm listing these out, I ignore the exponents. X minus 2 and then 8x plus 1. So what we do with the two outer whole number factors is common denominator that. Now I think 24 and 3 are the lowest common multiples. So let's take 24. I think 24 is in 3's row. Okay, I think 24 is a multiple of 3. So that'd be 24. So what we want to do is get these both. Well, that already is at 24, but this needs to get to 24. I times 3 by 8, and now it's 24. But then that 8 factor I brought in, now it goes to the top. Okay, so x minus 2 on the here I got it, and it's to the 2/3 power. Here I don't have it. It's to the that means I don't have it. I'm going to bring in this parentheses to the 2/3 power in here. But on top, I've already got that factor, so all I need to do is add a 2/3 to the 1/3, but that's one whole, so we can now eliminate the exponent. Okay, now 8x plus 1, what do we got for that? We don't have it in this denominator, and we have it here, and its power is 2/3. Okay, so in that first one, I'm going to bring in 8x plus 1 to the 2/3 power, so it matches over here. Now again, I've already got that up here, so I'm just going to add 2/3, and that's one whole. Gets rid of it. Okay, so now I have my common denominator. I have 24 times the parentheses of x minus 2, and then that parentheses is to the 2/3 power. Then you got 8x plus 1, and that parentheses is to the 2/3 power. Okay, so then we got 8 times 8x, which is 64x, and 8 times 1 is 8. And then over here, you don't have anything to distribute. It's just going to be plus 1x minus 2. So it's going to be 65x, then 8 minus 2 is 6. There you go.